Anyone tell me, it'll be easy, what are the coordinates corresponding down in quadrant 3, where the coordinates both should be this? What might you tell me the coordinates are based on what we're doing here? And you're reflecting back to 30. Negative radical 3 over 2 first. And the y coordinate should be? Gotta be. That's the only change taking place. Now, Jonathan, put you on the spot there, but can you now, be clever, tell the class what size is that angle that I just took from the initial all the way into it, made it terminate there. From here all the way around, it stops here. What size angle? I'll tell you this much, it's bigger than 180. Well, tell me in degrees first.
210.
210. That's what it's 210 degrees, 180 plus 30. And he's already converted it into what, 7 pi over?
I don't know how a good way to remember that. Like I
Remember
struggle
what?
that it's 7 pi over 6.
Oh, you just.
I'm like 5 pi over 6, and a pi would be 6 pi over 6,
Oh, I
and then 7
see.
pi over 6.
No. Why don't
I
you
don't
just go
know.
ahead and convert it by formula?
My formula.
Those conversion factors. So guys, this is of course, correspond with, in the green here, I'll finish this up. In the green, he's telling me, Professor, this is for 7 pi over 6. 210 degrees. Beautiful. Now we're on the side here. Another question here, number 2. Now let's try to find the tangent of 7 pi over 6. Whereas tangent's definition earlier was, place the y over the x. And if I look back with Jonathan's help, here we go. An 80. Right here it is, those are the coordinates. Place y over x, you place a negative 1/2 over a negative radical 3 over 2. That's what we got? So we have positive, 2's canceled. Now what does it look like simplified? I think it's radical 3 over 3, isn't it? Is it? There's the answer. Honey, you can't go wrong by this. Can't go wrong. Now which quadrant do I still have remaining? Quadrant 4. Gotta do the same thing, move it now into quadrant 4 and label and see what's going on here. That will be the end of that. Guys, quadrant 4, let's see if I can, boy, my sketch is getting all messed up here. I guess moving into quadrant 4, and this will be the last on this. Make it look like this. I'll place 30, I need to do a little erasing right here. Place 30 right here in the corner. And if you take a close look at it, go back into a 30-60 relationship. I need to know the coordinates at this point right here, in black. And from middle school, if I'm in quadrant 4, which I am, the coordinates should be these. So based on what I'm doing here, it should be merely what? Positive radical 3 over 2. There you go. Negative 1/2. Can't go wrong. It's quadrant 4. Bill?
Yeah.
Number 3. I would like to find cosecant of, and this will finish this one up. The angle, Philip, try blue. Go back to the initial side. Oh, let's do messy. And you're supposed to move all the way around and stop there.
So that would be, so one of the sides.
Well, no, I'm looking for the size of the angle.
So it would be like,
Give it to me in degrees or radians and we'll convert. I think it's 330. It's not a complete revolution, is it? No. In fact, this little place right here, what little angle here is what, 30? Does it make sense? This little piece right here, oh, it's blue here. This little piece right here is like what, 330? is 360 minus that little 30 in the corner, 330. 330 converted to radians is 11 pi over 6. So that's the size of the angle that I wish to look at. Place this right here. Messy. Now over here, this is where you're going to help me out, Phil. I want the cosecant of 11 pi over 6. And a little reminder, the definition says for cosecant is 1 over y. Nope. In this case, it's 1 over, what was the y coordinate back there?
Negative 1/2.
-1/2. Which is cute. It's -2. Caroline, I wish I was a type instructor, just pass out that handout I did yesterday. That unit circle's been drawn for you, right, on that handout. And just say, here it is. We have a test Friday, Saturday, whatever, Sunday, whatever test day is. But you have a sketch. Wouldn't that be nice? Because it's all done for you. And all you have to do is just take out the handout, look at the unit circle, and read numbers. And have no clue where those numbers came from. No clue. They didn't give you a clue in the handout. They just placed them on there. So you had no idea where they came from. And at least you know this much. Now, what's the issue before the break? There's some other special angles besides 30 that I must do this to. Now, they're going to go into as much detail. Look how much time it took me here on this for 30. Another special angle is, and I think I'm going to just list these for you when I finally get to them. Another special angle is, Professor, go back now, erase this, now do a 45. Do a 45 now. And then the last one is do a 60 in the corner here. You have the 30-degree angle, 45-degree angle, 60-degree angle, special angles, and then you go from there. Guys, how's it looking so far? Looking pretty good? And after you do all this, Miriam, here's the issue. When you do all this, you're feeling good, it's making sense for us. All of a sudden, you'll say, Professor Ramsey, on one of the tests there, you placed this. What are you talking about? Why did I place? You placed this. You want the, let's try sine, cosine, tangent. Let's try cotangent. You tried this. You want cotangent of 5, 5, or 12. Have you seen a 5, 5, or 12 in this circle? No. You guys who have your handout handy from yesterday, who has their handout handy there? Can someone flip that over and look at that unit circle? If you have the unit circle right in front of you, please look at it. Does anyone see a 5, 5, or 12 even on the handout? No. Is there an answer? Yes. But it's not on that circle. There's special angles listed on that unit circle. There are many angles left out. Now, I don't know myself the coordinates. I don't have 5, 5, or 12. By the way, can someone quickly tell me what size angle in degrees, it may help in degrees, am I talking about?
225.
Tell me again?
225.
Oh. If you convert it, use that conversion factor from yesterday. Take 5, 5, or 12, it's in radians. If you want to convert it, multiply it by a factor of, what was it guys, 180 over pi? That's just your factor there, 180 over pi. Pi's cancel, conversion factor. I know 12 goes into 180 nicely. It goes, I think, 15 times. And 5 times 15, I'm talking about a 75-degree angle. And I'm asking for the cotangent of 75 degrees. I don't see a 75-degree marked on this angle, circle. Even on the handout, they didn't mark 75 for you. They did not mark it there. So there's some angles that they did not mark, and I will not mark. Now I'm way ahead of myself. way ahead of myself. Okay, anyone tell me what, in this particular case, you might, as a clever student, try to do? 75 is not there, but do we have something that we could maybe relate back to the circle?
30 degrees?
Tell me more.
It's like a half angle or double angle?
Oh, now you're back, you're getting into the angles in chapter 6, the formulas. That means basically, what could you turn to now for help, since 75 is not there, it's not staring at you. And is there a cotangent for 75 degrees? There is. I just don't know what it is. Yeah, you may say, well, Professor, can you express 75 later on as 30 plus 45? And you did the 30 for us. And you said you're going to show me 45 here right after the break. So now you can maybe use those two in some manner and get what you want, you can. That's going to be chapter 6. Right now, I'm just concerned about what's on that circle. And 75 right now is not on that circle. Mr. Park, suppose, before I close down, we're going to take a break here in about 10 minutes. Help me out. Number 5. Let's try to find, say, I guess, make a sign. Sign of, I'm making these up. Let's try maybe 11 pi over 16. Do you think that's on the unit circle? 11 pi over 16? It's not on the unit circle today, is it? I didn't mention that 11 pi over 16 over there, did I? No, I had, what, 5 or 6. Mr. Parker, use your calculator or device you're using over there and see, maybe, is there an answer? Put your device in radian mode. Sine of 11 pi over 16. Maybe I threw one out there that can't be answered.
It's
Is
zero.
it approximate?
Yeah,
Okay, so it's not exact. It's an approximate answer. What's it approximate equal to?
0.83.
0.83.
Uh-huh.
If I should place that on a test, and you have no calculators, and all of a sudden I start squaring papers, and Aiden says, Professor, sine of 11 pi over 16 is 0.83. Aiden's finished, he can go home, he has an A for the course. He can relax and take the rest of the summer off. Who's going to write down 0.83? And no calculator. I'm not. I didn't know 0.83 myself. Mr. Park didn't know. Marina didn't know. Einstein even knew. That's 0.83. But it's not one of those on the circle. So all we're concerned about are those that will be on this unit circle. That's all we're worried about, those that are on that unit circle. Other angles do exist, but we can't deal with them unless we deal with calculators of some sort. Guys, making sense though? Everything's coming together for us on this? Making sense here? We're about to take a break. Now I'm going to step back here and look. Hang on. Yes, real quickly. I got just a few minutes. Not going to do much here. We're going to take a break. And someone, and I've been bragging on you guys. I told you some of my colleagues are asking me, Ramsey, you have any good students? Yeah, I said I have 31 of them. I have 31 now in class, not 31 good students. You want the entire class in Math 7? You got 31 right there. Your class is full. I've got 31 good students in this class. Now, so tell me before we take a break, just real briefly. Can anyone go back to the red? Those are my definitions. and give me, right now, one relationship you see among those trig functions and their definitions in the red.
What was the question?
Yeah, the definitions. Look at the definitions. And tell me one relationship among those results in red, that's their definitions. Tell me one relationship going on among those definitions. Go for it.
Do you want me to like all of them or just?
I'll just list before the break, just list one, I'll be happy.
Okay, sine and
Hang on, hang on.
cosine,
Wait. Let me get,
sine and cosine are inverse.
whoa. Not these two, they're not inverses,
Oh, you could say,
something more simple.
you could say.
But I guess you may be a little tired before you take a break. Miriam, give me one, then we'll take a break.
Tangent is sine over cosine.
Tangent's definition is y over x. But y is sine, x is cosine. She says, Professor, tan y over x is the same as saying sine over cosine, better expressed without letters. She said this. I'll come back to this after the break. Tangent can be expressed as this. That's y over x. The truth? Give me one more. Then we'll take a break. Give me one more. Anyone among those red definitions, she gave me one. Barbara, go for it.
Tangents multiplied by the cotangents as well?
Oh, you can fancy. No. Just keep it simple. Which may be true what you're gonna say, but let's keep it simple right now.
Secant is 1 over cosine.
Here we go.
Secant is 1 over cosine.
Wow. Secant is equal to 1 over cosine. Secant is 1 over x, and x is cosine. So you can express secant as 1 over cosine. And then I can list more for you after the break. And we will. I'm going to use them. Guys, I enjoyed this. Hope you enjoyed it. You got a 15-minute break? Oh yeah, 15 minutes.